So in this video lecture, we are going to try to learn how to resolve a forces into x component as well as the y component. If a point is going to be subjected to the single force, if you want to know what is the force acting in the x direction, what is the force acting in the y direction, so that we are going to be using here, that method is called the resolution of the force. What is the resolution of the force? As per the definition, the resolution of a force is the process. So, of the splitting up the given force into number of components. Again I am repeating, the resolution of a force is nothing but it's a process. What is the process here? We are going to be splitting up the given force into number of components. In which direction we are going to be? That depends on how we require in this case. Suppose a component is going to be resting on the horizontal plane. So then that force is going to be inclined to the x and y axis. So then we are going to be resolving the forces into y axis as well as the x components. So similarly, if the axis itself is going to be in inclined position, if you want to know what is the force acting along the inclined position, what is the normally to that force, that normally to that the plane, we are going to be calculating from this resolution. So here it is the process of finding the components of the force along the two rectangle axes x as well as the y. So in this case what we define, it is the process, the splitting up the given force into number of forces. So then in this case what I am going to say, the process is the finding the components of the force along the rectangle axis x as well as the y. In the here I am going to give one example, and that force is going to be acting through the point, and how we are going to be resolving that we are going to be finding. So I am going to be considering here one of the rigid body in irregular shape I have taken. So then in this case what happened, I am going to be taking the one force is going to be acting in this direction. So what the force is going to be acting in this direction. So we need to resolve the forces into x component as well as the y component. So then for this one I am going to be taking the axis, that means in the x direction, and the y direction, two axes I have taken. I am going to be assuming that it is going to be making an angle theta. Right? So that is going to be making with the horizontal surface. So then how could you resolve the forces in this forces? So for this one I am going to be resolving the forces. So for this one I am going to be taking, so here is going to be the point of origin O I am going to be taking here. So that is the O, and this force is going to be acting in the direction of at an inclination to the horizontal plane. Right? This is going to be making a theta. So then what I am going to do, I am going to be taking the projection of these points, I am going to be taking in this direction as well as in this direction. So this point I am going to be say the A, and this is the point I am going to be say the B. So by this vector diagram we got it, this force is going to be acting towards this side. OA and the AB, for the two components I have taken, one is in the vertical direction, one is in the horizontal direction. So then what I am going to say, from this triangle OAB, so then how could you find out the magnitude of the OA? That magnitude how we are going to be finding here, because this is the force is going to be the F force is going to be acting towards this side. If for this one we are using the trigonometry here, the sin theta or maybe the cos theta. If I am going to be taking the sin theta, so this is going to be opposite side is going to be the AB, by hypotenuse that is going to be the OB. So for suppose the sin theta, if I am going to be taking, the sin theta is going to be represented here opposite side, that's going to be the AB divided by OB. This is going to be the length of this vector. That length of the vector is going to be representing the magnitude of that force. So then we need to calculate the AB. So from this one, AB is equal to, what is the formula here? That's going to be OB into sin theta. What is the OB here? That is equal to the applied force on a rigid body. That's going to be F sin theta, we got it. So that AB, I am going to be say F, so this is going to be your, AB is in the vertical component, that's why I am saying Fy is equal to F sin theta. Alright, so this way we are going to be calculating. So this, and similarly OA, how we are going to be calculating the OA here, that I am going to be taking here is the cos theta. So then cos theta is equal to, what is the formula? Adjacent side, that is going to be OA divided by OB. And similarly OA is equal to OB into cos theta. So OB is equal to, that is going to be the applied force F. That's going to be F cos theta, we got it. and then this OA is going to be representing the horizontal axis that I am going to be taking the fx, that is equal to here, that's going to be f cos theta we got it. So this way we are going to be resolving into the two components, x component as well as the y component. So then I am going to be simplifying this diagram. So that's going to be, this is the origin O and this is the force is going to be acting in this direction. We resolve the forces into horizontal component as well as the vertical component. So in this case, that's fx is going to be in this direction, and similarly y direction is going to be this one, this is the fy. So in this case we are going to be already be told they are the rectangle components in this case, because the rectangle component two sides are making at 90 degrees to each other. So because the point of origin is going to be the O, then the resultant components also is, suppose F is the resultant component, that is the applied force that we resolve into the Fx as well as the Fy. These forces also moving in the same direction. Suppose this OA is going to be moving in this direction and AB is going to be in the vertically upward direction, because this particle is going to be making X component as well as the Y component. This is going to be increment order we do have in the OA direction and increment order in the OB direction. If you are going to be see, if you are measuring 1, 2, 3, 4, in this case also 1, 2, 3, 4. So then what will happen, each and every time that increment order is going to be there, then it is clear that the direction of the horizontal component is going to be towards the right side, and similarly the Y component increment order is in the upward direction, then the direction is going to be in this direction. This way we are going to be solving the problems.